Good morning to all. Welcome to this new session of circuit theory class. So today we will continue with what we have left in the last class. So we were talking about the AC circuits. Okay, and the main objective is that whatever we have learned for the DC circuit, the same we have to say for the AC circuit also. Okay, so let us start. Okay. Some point we have already discussed it, okay, and among them was one of them was the time. Okay, I have already told you what a time is. Clear? So time is very clear to you that it is the amount of the time taken by alternating quantity, which can be a voltage or current, to complete one cycle is called time period T, and it is inverse of the frequency. So how will you define frequency? Definitely, okay, the number of cycle per second is called the frequency of the alternating quantity, and its unit is hertz, capital H and a small z. Okay, so Hertz was a scientist. So all the units you will see in electrical engineering are named after certain scientists to give him recognition. For example, your volt, the unit of voltage, was also a scientist. Similarly, ampere was also a scientist. So all they were scientists. So their name has been put forward before the as a unit for the different electrical quantities. Okay, so when I say 50 hertz, what does this mean? When I say 50 hertz, it is very clear that in 1 second, that alternating quantity is completing 50 cycles. Okay, and we cannot see it with the naked eyes. Okay, because our perception power of our eye is only up to 20 hertz. Okay, so we cannot see with our naked eyes the alternating quantity which is flowing in our household services, either in the socket or in the wires or all this. Is it clear? So next move to the another point. Then come the amplitude. You all know these values. Just for the sake of revision, I'm repeating it. So the maximum positive or negative value of an alternating quantity is called its amplitude. Okay. And one more important thing, the standard form of the alternating voltage is being written as E is equal to, now one more thing, instantaneous quantities are always written in small letters, while the peak value or the DC value or the average value, they are all written by the capital letters. Now you see that this is the standard equation. Okay, now in this standard equation you can see E is the instantaneous voltage, the small e is the instantaneous voltage, em is the maximum or the amplitude of that alternating quantity, and because it is being sinusoidal in nature, therefore it is represented by sine theta. So this sine theta is also written as omega t, where omega is the angular speed, radian per second, or it can also in terms of frequency we can write as 2 pi f. Okay, and f can also be written as 1 upon t, therefore we can write down em sine 2 pi by tt. So these are the standard form. In any one form you will have the sinusoidal quantity representation. Okay, so it is very clear. So you can find out corresponding frequency. Okay, suppose you have been given, I gave you example, E is equal to given as 20 sine, oh sorry, uh, 20 sine, say 314t. Okay, like in this example. Okay, what you have to do, so 50 is the, so here in case 20 is the amplitude. Okay, in order to find out the frequency, this is representing omega. So omega is equal to 314 and omega is equal to 2 pi f. Therefore f is equal to 314 divided by 2 pi. Okay, which will come out to be 50 hertz. Very clear. So you need not have to confused. Okay, because it is not ft, it is omega t, and omega t is 2 pi f or 2 pi by t. Okay, so it is very clear that how to represent an alternating quantity. Okay, so next come an important topic, phase. This is a very important topic. What this phase is basically. Okay, generally I will ask any student that what is phase, then it is a vector. Okay, then why another name has been put forward, phase. So today we will understand what the phase is there. Okay, now what happens in case of mechanical or in mechanics, you have learned about the vector. So vector, what is the vector? That the quantity which has magnitude as well as direction. Okay, now this is spatial direction. This is spatial direction. So for spatial direction, what you do in mechanics, आप मैकेनिक्स में क्या करते हैं कि आप स्पेशल डायरेक्शन देते हैं किसी भी क्वांटिटी के साथ कि ये फुटबॉल जो मैंने मारी ये 10 मीटर पर गिरी और ये 30 डिग्री एंगल पर गई. इज इट क्लियर? तो 30 डिग्री क्या है हमारा स्पेशल डायरेक्शन. उसके लिए हमें क्या करना पड़ता है? उसके लिए हमें एक रेफरेंस लेना पड़ता है. We have to choose a reference, okay, and we draw two lines. One is horizontal, one is vertical. This is the origin, and with respect to this, we will define. Oh, this is making an angle of 30 degree, okay, and its magnitude is 5. So it is we represent it by as a 5 angle 30 degree. Now this 30 degree is what? Sorry, I could not write in proper way. I'm sorry. So it is. So say this is angle, okay, and there you write 30 degree, okay, degree. So 30 degree is the angle traced out by the corresponding quantity in the anti-clockwise direction. So you represented this by vector. Now here in our electrical quantities, what happens? Because you see that if you look toward a socket in your electrical household, you will find that every time there is the current is flowing in that particular hole of that socket only. Voltage is there in the socket only. So no spatial change is there. At space, from space point of view, it is at the same location. So how we cannot call this a vector, but it's still something is changing. And what is changing? Its magnitude is changing with respect to time. Okay, so let us say you have a socket in your home, okay, and you will find that at the time t is equal to 0, its value is 0. If you keep on measuring, you will find that at t is equal to 1, it is different. T is equal to 2. At t is equal to t by 4, its time is how much? It is a maximum. Then at t is equal to t by 2, okay, it is 0, once again 0. So it was 0 at the origin and it is again 0 at after time capital T by 2, where T is the time period, that is time taken to complete one cycle. Then again we will find that now the value is of the current or voltage is negative. So again it is increasing negative. Again it reached to a maximum negative value. Okay, after 3 pi by 2, after 3t by 4 seconds, and then after again you will see that at a particular time, that is after time t seconds, it will become 0. Okay, in this way we found that with the no doubt the location is same, space is same, but with time it is changing. Okay, it is changing, the magnitude is changing. So we call such quantities not as a vector, but we call it as a phasor. So such quantities whose value changes with respect to time, they are being called as phasors. They are being called as phasors, and the corresponding angle is known as the with respect to certain reference. और इनका ये जो एंगल है किसी रेफरेंस के संदर्भ में क्या कहलाता है? फेज एंगल. And the quantities are called phasor. If you have any doubt regarding this, please write in the chat box. I am ready to reply. Please write in the chat box if you haven't understand phase. Phase is nothing but these are the quantities, okay, whose values continuously changes with the time. Okay, with respect to direction also and magnitude also, they keeps on changing. So previously it was having positive direction in this direction, and every time the magnitude is changing. Okay, and here it is negative value and direction is also negative. So please write in the chat box if you have any problem. So basically they are not vectors, but they behave as a vectors. You will surprised to know that the phasor algebra is nothing but It is very similar to the vector algebra, but we cannot call it as an vector algebra. We call it as an phasor algebra, and their all laws are similar to the vector algebra. Okay, that is, they obey all additivity law, the subtractive law, associative law, commutative law as per the vector algebra. And such quantities, electrical quantities, whose value continuously changes with the time, okay, they are known as the phasor quantities. Okay, all voltage, current in our AC circuits, even power are all phasor quantities. So now onwards, we treat it as a phasor. So in phasor, we will have a magnitude as well as a angle. Now you will surprised to know, sir, you have said time is changing. Okay, so why here angle has come? In case of mechanical quantities where they are treated vector, angle is no doubt giving the direction. So why you have taken angle? Basically, we have converted the changing time into angle. Okay, we have converted changing time into angle, and therefore that angle is called phase angle. Okay, for our mathematical simplicity purpose, we have converted the time, the changing time, into corresponding angle. How? Now see that it has been converted. See, if you have any doubt so far, before I proceed further, please write something in the chat box. You have understood the thing, or still things are not okay? 21 participants are there and no one is okay. Every time I see only 3 or 4 persons like Hardik Singh. Okay, he used to write. This time Sukhdeep Kaur, okay, Himanshu Dosia, very good. You are writing something means you are acting, and if you are not writing something means things are not fine. What about Aishwarya Nahar? If you have any doubt, Garvesh, okay, fine, good. Anita Kumari, Anjali Gupta, Anurati. If any quantity magnitude changing, no magnitude but direction, it is a DC fluctuating quantity. I have already told you. If suppose I have already told you, yes, somebody has asked the question. Divyarth, see, I have already told you. Let's say this is your time axis and this is your magnitude. If it is like this, okay, direction is same. Okay, direction is same, but the magnitude is fluctuating. So it is called fluctuating quantity. It is called fluctuating quantity. It is not phasor. So still many people have not responded. Keshav has responded. It means people are sleeping. They just switch on the mobile and thus seeing the TV and all everything. Lakshman Singh, Pranjal, Yogesh, no doubt. Okay. So now let's come. It is being we have to represent a time, the changing time with respect to that phasor quantity. Then where have come this angle? Okay, what do you mean by this angle? Okay, so we will take into account how this angle has come into picture. Okay, so how it has come? So let us discuss it. Now you see that time is changing, and T means one cycle. Capital T means one cycle. Everybody agrees? Okay. Capital T means one cycle. Okay. One cycle means whenever I say one cycle, it generally comes like this. End points and the beginning points are meeting. Okay. So it is making an angle of how much? 360 degree. 0, 1, 10, 20, 30, 90, 180, 270 and 360 degree. So whenever a cycle is there, okay, our mind comes that yes, something end points and beginning points are meeting, and so angle traverses 360 degree. So that 360 degree is also being written as, in terms of pi, it is also being written as 2 pi. So I can write down T. When I say T, T means time taken to complete one cycle. So, and one cycle is nothing but 2 pi. Okay. So in 1 second, how much it will be there? 2 pi by T, as per the unitary principle, 2 pi by T. Okay. Now I have to convert. So 2 pi, whenever 2 pi comes, This is the angle. 2 pi means angle. So if I ask, when one cycle is complete, how much angle is traversed by that given quantity? You will definitely say, so 360 degree. Or not in degree, in radians, then you say 2 pi radians. Okay. Or in 1 second, 2 pi by t radians. So if I say in small t, any time t, it can be like this time 1, 2, 3, 4, any time t, then the angle traversed will be nothing but 2 pi by t upon t into small t. Okay, this small t is in numerator. So as per unitary principle, okay, so this is that's how, therefore we have converted the time into angle for our mathematical simplicity. Okay, so from now onwards, instead of speaking in the time, changing time, we will speak in the angle term. So I will say when 30 degree, 30 degree is representing its angle. So angle. So this is 0 angle. When I say t by 4, this time is capital T by 4. See, look towards the diagram. Okay, t by 4. So if I substitute t by 4, t will cancel 2, so it will come by pi by 4. So when I am saying pi by 4, or also pi by 4 is radians. Pi by 4 is in radians. So in degree it is how much? 45 degree. In degree it is 45 degrees. So 45 degree means, when I say the given quantity has a phase of 45 degree, it means it has started at t by 4 times. It has started at t by 4 times. Okay. Suppose I say the phase of a given alternating quantity is pi radians. Is pi radian. What does this mean? Pi corresponds to this. This is how much? T by 2. You can verify. Place T by 2 here. T will cancel. 2 will cancel. You are left with pi. So pi corresponds to this. Okay, the pi radians, or it is in angle terms, it is 180 degree. In terms of angle, pi radian is equal to how much? 180 degree. From mathematics, you know it. So basically, we are converting the time into corresponding either in angle, either in radian or in degree for our mathematical simplicity purpose. And this angle is called phase angle, and the alternating quantity is called phasors. The alternating quantity is called phasors, and it is with respect to certain reference. For example, in mechanics also, when I say a ball is thrown at an angle of 30 degree, then I can make a 30 degree only with respect to certain reference line, 0 degree line. Then I can say, yes, if this is 0 degree, then this is 30 degree. Okay, if I don't have the reference line, similarly, I will not able to express my angle. So here also, if I want to have an angle, I have to express my time into angle, I should have a reference. So I have taken this as a reference. So the absolute value of the angle with respect to reference is called the phase angle. Okay, you got my point? Any doubt? If any doubt, please write in the chat box. I can repeat it. Only 2-3% Garvesh, like Garvesh, Divyar, this time Govind. Okay, no doubt. Okay, no doubt. You are very intelligent students, really. You people never have any doubts. Okay. If you have no doubts, probably you are the intelligent most community of this world. Now, come the concept of the phase difference. Okay. What is phase difference? Okay. So what happens? I have taken to explain this phase difference. So whenever you have to make comparison between two alternating quantities, there comes the role of phase difference. So out of the three quantities, suppose there are three quantities are there. Okay. So out of that one quantity, you have make it one quantity as a reference, or you can choose a fourth quantity as reference and express the third in respect with respect to that fourth. Express the three quantities with respect to the with respect to the reference quantity. But in general, what happens? We take one of the quantity as a reference and express the remaining quantity with respect to this. Okay, I have already told you that in mechanics also, when you say 30 degree, it means it should be expressed with respect to some reference line, 0 degree line. Okay, here also we require a reference line, reference alternating quantity, with the help of which we can express the phase angle of the other, and the difference between their angle is called the phase difference. Okay, the phase difference is nothing but a simple English word Okay, the difference of the phases. Okay, so one of them will be the reference and another will be the alternating quantity phase with respect to that reference, or it can be between the other two quantities. So let's say understand this waveform. A, B, C are three waveform. A I have chosen as a reference. Okay, starting from t is equal to 0. B have start at angle of beta and C has started at angle of alpha plus beta. Okay, so you can see I can say that quantity A, alternating quantity A has a phase angle of 0 degree, while alternating quantity B has a phase angle of beta, and while the C has a phase angle of alpha plus beta. Is it clear? And now if I want to know what is the phase difference between B and A, then nothing but beta minus 0 beta. Similarly, between C and A, it is alpha plus beta minus 0 alpha plus beta. So in this way, we can find out the phase difference between the two alternating quantities. So phase difference plays a role whenever there is a more than one quantity, one alternating quantity. Otherwise, each alternating quantity has its own phase. Phase difference exists whenever we have to compare the phases of the two alternating quantity, two or more than two alternating quantities. Now, next come another value called RMS value. Okay. So, phase difference is clear. Next come the RMS value. Root mean square value. Okay. Now, this root mean square value is also in short form known as RMS. Okay. And is given by that steady current. Steady means DC current, which when flowing through a given circuit for a given time produces the same heat. Now, this is the definition as produced by the alternating current when flowing through the same circuit for the same time. So, basically what happens that RMS value, as the name suggests, root mean square. So mathematically, it is the mathematical name. Okay. So you have to start from your right hand side, that is from the square. So whatever the alternating quantity is being given to you, you square it. Then mean means average. You take its average and then take its under root. So you will get the RMS value of a given alternating quantity. Basically, what happens if you take the average value of any alternating quantity, symmetrical alternating quantity, its average value comes out to be 0. But what happens? The current is flowing, and due to this current, heat is being generated. Okay, then it means we cannot say that nothing is going on. 0 means nothing is going on, because when you take the average value, positive will cancel the negative, so you will get 0. 0, however, the alternating quantity produces heat. So heat has been chosen as a benchmark, okay, which dictates no, some current is flowing through it, flowing through that given circuit, and that current we will calculate as an RMS value. Root means square value. Mathematically, how to calculate? You take the square of the start from the last, not from the first. So start from the last, take square, then take average, and then take root. Okay, you will get the RMS value of a given alternating quantity. And heat has been chosen as a benchmark to find out this RMS value. It is also known as effective value or the virtual value. Okay, generally RMS value is the common name, but in questions you will may find effective or the virtual values. Okay, and to demonstrate this experiment is there that you connect a wattmeter, okay, apply a DC voltage V, okay, and measure the power consumed by this resistor R with the help of this wattmeter. Okay, now you apply a same AC voltage of magnitude equal to whose amplitude is equal to the voltage V. Okay, and then apply to it, then you will find that the some heat is again produced in it. Okay, and when we compare this heat, we'll find that the current which come out to be is known as the root mean square value. Some current will be coming through it, that will be called as RMS value. And another come how to find out the RMS value. There are many methods are there. One method is that mid-ordinate method, which you have learned in your lower classes. Okay, that what happens that you choose the some points, okay, like this points, you find out their mid ordinates. Okay, means the average value of these two. Okay, so these are the 2 points you have chosen. So I1 is the mid ordinate, I2 is the mid ordinate between this, I3 is the mid ordinate between this. Okay, so basically what you are doing, that divide your time base into n equal intervals of time, each of duration t by n. Okay, you can choose any n value and then divide into t by n. So what will happen? This is t1 by n, this is again t by n, this is again t by n. So like this way we have divided it. Then calculate their average value, that is the mid ordinate value, I1, I2, I3, I like this way. Okay, and then you can calculate the RMS value by the method under root I1 square plus I2 square plus I3 square divided by total n, that is the, find out the mean square and then take its under root, you will get the corresponding RMS value. This is the analytical method which is being widely used. The analytical method simply you have to go to the definition. Root mean square starting from the last. First of all, let us say the current is I. Let us say my alternating current is I. So I can express as I am sine omega t, okay, or I am sine theta. So as per definition, take square this alternating quantity I. I have taken I square. Then take its average. Okay. So to take the average, what I have to do? I have to use the integration formula. So 2 pi by minus 0 and integration from 0 to 2 pi. This is the, I have taken the average or the mean. Okay, by the integration methods. How you take the mean of this? You take with the of this, what are the limits 0 to 2 pi and divide by the total interval. So total interval is between 0 to 2 pi. Now then afterward root mean square. So you take the under root of this quantity, the whatever the mathematical value you will got, it is known as RMS value. So when you calculate of this I am sine omega t or I am sine theta, you will solve it, then you will get, it comes out to be I am by root 2, and root 1 upon root 2 is nothing but 0.707 I am. So you can remember it, the RMS value is nothing but 0.707 of the maximum value of the current. Okay, so we will not go into detail because this is some when we come across the another topic. Average value. Okay, though this would have come first, but now it is coming secondly, no doubt. Average is nothing but the mean value. Okay, so mean value, how you calculate? You take the all the different values, okay, and divide by the number of the values you have taken, then you will get the average value. But in case of symmetrical alternating current, you will always get the average value is to 0. So in that case, we do not consider that average value is 0, but in that case we will take the RMS value, or we will calculate the average value for half cycle. So keep in mind, for the symmetrical waveform, if average value is asking, then for the complete cycle it is 0. But in order to give a mathematical value, we calculate the average value for a half cycle only. However, for the unsymmetrical alternating waveform like half wave rectified waveform, the average value is always taken for the complete whole cycle. This you have to keep in the mind. And there is a ratio called form factor. Okay, the form factor, in fact, form means shape. Form is the shape. How the shape will look like. Okay, so the form factor Kf for a sinusoidal waveform is nothing, is defined as, first of all, for any alternating quantity is defined as RMS value upon average value. So do remember this formula. Okay, this formula for the form factor, it is defined as RMS value upon average value. Now RMS value for a sinusoidal alternating current is 0.707 IM, while the average value for a half cycle, it comes out to be 0.637 IM. IM will cancel, and when you will solve it, the form factor comes out to be 1.11. So that's what this form factor shows. This shows that there is no change in the shape of the system from RMS to the average value. Both are nearby same. Okay, so higher the value of the form factor means more distortion is there in the waveform. However, in case of sinusoidal waveform, the distortion is very less, and therefore the form factor is near about unity. And mathematically, this formula is very useful because with the help of this, you can calculate the so-called the RMS value of any given quantity once you have once you know the form factor and the average value of a given given alternating quantity. So RMS value half wave rectified current, as I have shown you how to calculate it. Half wave rectified means this portion is absent, this dotted portion is absent, and you have only half cycle 0 to pi. This is obtained in the case of half wave rectified. Okay, you might have learned in the electronics. So this is, you will get only half cycle, then 0, then another half cycle, and then 0. So you have to find out the RMS value of this. Very simple. Okay, you know that the one cycle is so you calculate the so-called average value. So how will you calculate it? The complete cycle is 2 pi, okay, but it will exist only for pi, 2 pi to pi, its value is 0. So you will break the integration and you will consider only from 0 to pi. However, the time period is 2 pi to 0, because no doubt this is 0. So you will make, when you break the integration, you will make 2 pi is 0. So do calculate at your home that what is the RMS value of an half wave rectified waveform. Similarly, you can calculate the average waveform. Okay, the average waveform is, no doubt, the formula is no doubt here I have written 2 pi, but mind it how to solve it. I will just give you this. I average is nothing but, first of all, write down the limits. 0 will be the starting point, and this will be the total time of the one cycle, 2 pi. No doubt it is completing one cycle. So I d theta upon 2 pi time period, total time period, 2 pi minus 0. Okay, now instead of I, now see, if I break this integration, then what I will find that 0 up to 0 to pi, there exists the function Im sine theta. But between pi to 2 pi, this does not exist, it is 0. Okay, so I can simply remove it and I can write down here. You will, in the examination, you will write the complete step. No doubt, you will break this integration from 0 to pi, then plus pi to 2 pi. But when you write pi to 2 pi integration, there you will write the function as a 0. 0 रखेंगे वहां पर, क्योंकि वहां पे कोई एग्जिस्ट ही नहीं करता. आप देख लीजिए, कोई एग्जिस्ट ही नहीं करता. अब आप इसको सॉल्व करेंगे, आई की जगह क्या रखेंगे, आई एम साइन थीटा. आप सॉल्व करेंगे, आपको कितना मिलेगा, एवरेज वैल्यू आई एम बाय पाई. Okay, so Im by pi is the average value of a given half wave rectified. In this way, you can find out the average value of any given waveform. The RMS value will come out to be Im by 2. Okay, that you can verify it also with the help of the formula, and ultimately it will come over 1.57. So it has increased from 1.1 to 1.57. There is a great distortion is there. Okay, this is very clear from the this form factor. How to represent? Now this is the important point, how to represent an alternating quantity. Okay, so we will be using the same thing as we have used in the vectors. So they are being represented as a vector only, but how to represent it, that should be clear. Okay, for example, you have a sinusoidal waveform like this, E is equal to Em sin omega t. Now omega t is the angle in the radians. Okay, it can be theta also, or it can be expressed as omega t also, where omega is nothing but 2 pi by t. I have already told you how to convert the time into angle. Okay, so what happens if I take any point, let's say this point on this waveform. So how to represent this waveform? Suppose it is making an angle of omega t. Okay, let's say, and this is the point where we have to, small e is the value. So how will we represent? The magnitude is, say, suppose 5 volt. So I will draw two lines, straight line, okay, horizontal and vertical lines, just as we have in a Cartesian coordinate system. Make the meeting point as a origin. Okay, now from the origin I will draw a straight line of magnitude equal to the amplitude at this point at an angle of omega t. So this p is representing the phasor at this quantity. Okay. Similarly, if I take this maximum point, so how much is this maximum point? This is the maximum value is Em. I will draw a vector making an angle of how much? It is very clear, pi by 4. Pi by 4 is nothing, sorry, it is making an angle of pi by 2. So pi by 2 is nothing but an angle of 90 degrees. So it is here, it will be like this. It is there. So it is very clear from this that how to draw a phasor. Suppose now at this point, where will be this point? This point will be here. This point, no, so magnitude is 0. So this will be point will be here. It will be 180 degree. It will corresponding to when it is on this side, it will be 180 degree. So in this way, suppose I take another point like this. Okay, let's say it is making an angle of oh sorry, I take this point, I want to represent it on phasor representation. Let it is making an angle of theta 1. Okay, so I will draw a straight line equal to magnitude of this at an angle of theta 1. Okay, so that's how the vectors are being, that's how the phasors are being represented on a graph paper. Okay, so it is very clear how to represent the phasors. Okay, so you can see that let us say two waveform, one is the current waveform, another is the voltage waveform. So you can see this is the voltage waveform which is advancing by an angle of alpha. This is the reference I have taken as the current starting at t is equal to 0, but this has started before this only by angle of alpha. Okay, so I will draw what will happen. First of all, if I want to draw how I can represent it, I will draw the current Im. Okay, making angle of suppose a maximum point I have to draw it. Okay, so this is the maximum point which will be at angle alpha, and while this will be at alpha plus omega t. So this will be the corresponding phasor diagram of the corresponding EM and IM. Okay, in foreign author books, generally maximum values are being taken for drawing the phasor diagram, while in Indian author books, some Indian author books, the RMS value is also being taken as an phasor magnitude as of the phasor quantity in drawing the phasor diagram. Okay, so just as we have a vector law of algebra, that the how it is being written, vector law, if you remember that the resultant v is nothing but v1 plus v2. So here also the same law is there, that if two vectors are there, let's say e1 and e2, e1 is one voltage, e2 is another voltage. Okay, then the vector law says that er is equal to e1 plus e2. Now how to represent on books, on copies, how to represent? In books you will find that vectors are represented by bold letters. So these phasors are represented by bold letters. But when we write in the copy, what we do, that suppose my E1 is there, okay, my voltage is there, which is E1. Okay, so how we represent in the copy? E1, okay, I will put a bar below it, either a bar below it, or some books, some people write above the bar. So whatever convention you can use it. Okay, if you are using a bar above or below, it means it is a phasor quantity. It is a phasor quantity. Okay, while in books you will find that phasor quantities are in bold letters, bold fonts. Okay, so immediately you can find out, yes, it is a vector quantity. Okay, so be cautious in this. And for example, suppose I want to say what is the resultant of these two, then again I have to obey the vector law only. So the phasor law are nothing but the vector law only, but the quantities, these two quantities are different quantities. Now next come the AC through resistance, inductance, and capacitance. Okay, this is a very basic. Okay, you should know it, that how to take into account the phase. What will be the phase angle when AC is passed through a resistance and passed through inductance and capacitance. That will take tomorrow. Okay, today only this much only, that we have gone through some basic concepts of the AC. Tomorrow we'll go through that what will be the reaction of the AC when it is passed through resistance, inductance, capacitance, and then we will proceed to the different theorems related to the AC. So any doubts so far? Please write in the chat box. Please write. No doubt. Okay, fine. Then good. I am ending the meeting if you are not finding any problem.